Thank you for introducing me. Can you hear me properly? Is it fine for you? Great. Welcome to my talk. Together with my colleagues, we prepared a presentation about Kubernetes SDN, performance, and its evolution at a scale. Most of the work was performed by Jakub and Marek, but unfortunately they were not able to attend this talk. So I'm here to present our results. I will take you through our findings, ideas, and the experience from the testing. Oh. Sorry. So briefly about us, as I have been introduced, my name is Tomáš Kukrál. I work as a cloud architect at Mirantis and in a product engineering team. I'm responsible for Kubernetes components in our Mirantis cloud platform. And I'm working with Jakub and Marek on building converged networks for Kubernetes, virtual machines, and physical machines. And this work evaluates the architecture for different use cases. And as you probably noticed, I shouldn't be the speaker for this talk previously, but Jakub wasn't able to attend, so I'm here for you to present our results. So my talk is divided into 4 parts. In the first part, I will give you the introduction to plugins, and I will describe how it works, and I will describe the decision whether to use overlay or non-overlay networking. In the second part, I will be talking about the Calico. The next part will be about the Open Control, how it works, what is the differences between the Calico, and why we decided to use it. And the last part, in the last part, I will try to compare solutions and evaluate use cases for these networking plugins. So at the beginning, when the containers appeared, it was kind of ignored by the production. And the main reason for it was that the container started something like a playground for developers. Nobody was brave enough to run it in production. Yeah, we had the containers for many years, but I think that the real boom for containers started with Docker because they prepared the ecosystem for it and made it easier for us. But it was still not ready to be used in production from our point of view. It was easy to run containers on your computer, but there were several problems. For example, how to orchestrate them. There were problems with disaster recovery scenarios. And of course, there were problems in networking. There were some important features still missing. And usually at the beginning of the containers, it was necessary to manually map the ports from container to the outside world. However, it was obvious that the containers will find its way to production. And from my point of view, containers become more serious when we get Kubernetes, once the Kubernetes was released. Because the Kubernetes solved many problems and unfortunately created new ones. And it's giving us an abstraction layer over the containers and their connections. It was no longer necessary to manually map the ports from containers to the outside world. In the terms of Kubernetes, we are using something called pod. It's basically the group of containers, and this group is sharing the same primitives, like localhost and some signaling between the processes. And we don't need to care about IP address of this pod anymore, because we are exposing services using these pods using services and ingresses with balancing. So the IP address of this pod change each time we run the new pod or we update the version of the pod. And it's necessary to use the services to route your traffic to this pod. And there are different approaches how to do multi-host networking. Of course, if you have just one host, you don't need to care about the overlay or non-overlay. You are just running on localhost for everything. But if you have many hosts, you need to provide some networking between these hosts. So there are different approaches. First decision is whether to use overlay networking or non-overlay networking. This is usually the main one. And the next questions are if you need a multi-tenancy and a security, because there may be situations when you don't need these features, and you are fine without them. And the next questions are about the performance and the scaling. We have many different plugins for Kubernetes. It's similar to OpenStack Neutron, which have so many plugins as well. There is a list of few of them. You can see the Calico here, or OpenContrail. The little bit less known are the Romana, Weave, Contif, and OpenVSwitch, and many others. For example, there can be Flanner as well. And since Jakub and Marek are OpenContrail experts with years of experience with OpenContrail in OpenStack, so we wanted to compare the solutions we are using in OpenStack and compare them to Kubernetes. So we choose Calico and OpenContrail for a comparison. And the reason why we choose Calico as the second one is that the Calico is used in many existing deployments, and it's promising really interesting features. And from our point of view, these two are looking like most production ready, in our opinion. So the first question is overlay or non-overlay. There are basically two ways. There is a simple non-overlay networking and a more complicated overlay networking. And of course, there are some concerns about the overlay. We have heard many times that people are afraid that it's too complicated for them. They will use benefits of simplicity. They will lose the performance because the overlay is using encapsulation. So you will definitely not be as fast as with the non-overlay network. And it also can be difficult to maintain and troubleshoot these networks because basically we are running network in a network. So it looks kind of weird. And of course, there are some benefits, which are usually the reasons why people choose overlay networking. And if they need multi-tenancy, some security, or micro-segmentation. If you don't have overlay, it's much harder to provide these features. You can have a layer 2 connection between your pods. You can have layer 3 or different kind of VPNs. And one feature which is usually required for a production environment is analytics. So the companies are running, for example, OpenContrail, and they like the analytics features, and they want to use it in their containers as well. But the concern, which is usually used very often, is only the performance. So everybody is afraid that their network will be too slow. But I think that the performance shouldn't be only the reason why you are deciding which one you want to use. The most important one is the complexity of your solution. If you don't need any advanced features, so then don't make your networking too complex and use which suits you well. So for example, if you have dedicated cluster for your application and you don't need advanced network isolation, and you are fine that your networking between the containers will be shared with your physical infrastructure, so the non-overlay networking will be probably fine for you. But if you request advanced features like analytics, connection to legacy infrastructure, or managing external endpoints, for example, your legacy infrastructure or VMs, then you will probably need to use overlay networking. It's not possible to decide which one is better because it really depends on your use case. So we tried multiple scenarios in our testing environment and executed functional tests and the performance ones. We have been running Calico on bare metal. We have been running OpenContrail on bare metal. OpenContrail in several versions. We started with 2.x, then we moved to 3.x, and now we are evaluating current master version, which will be probably released as 4.x. We have been running OpenContrail on Calico, on Kubernetes with Calico, OpenContrail and Kubernetes next together, OpenContrail in OpenStack with OpenContrail, using OpenContrail as data plane, And for example, for Calico in OpenStack with OpenContrail, we use a feature called BGP as a service. So let's move in more details about the Calico one. We have been evaluating Calico since Kubernetes 1.1. And currently, we are presenting Calico as the default non-overlay networking in Mirantis Cloud Platform. So Calico is using CNI networking plugin. CNI stands for Container Network Interface. And this interface gives us an abstraction layer for configuring the interfaces. And basically, it connects your interfaces in our containers to the rest of your network. Calico is using BERT as well for BGP stuff, and ATCD is a persistent key value store. Convd is used for generating configuration file. The Felix is only one which is really working in it. So the Felix is running on each Calico node and configure your IP tables. And the Calico is pure layer free. So it means that there is only routing and no additional encapsulation. So let's take a look at the example Calico network. You can see, at the bottom you can see we have many hosts, and the blue parts are the network. And the thing how Calico is working, that you will assign part of your network IP space to Calico, and it will divide these IP space to smaller ones and give host network to each host in here. So if you will spin a pod, for example, on this node, it will get IP address from this host network. But you need your other host to be aware of this IP address because, for example, you need to communicate this way between those computes. So if you will spin a pod here, you will distribute routing information using BGP, and the rest of your network should be aware of this IP address of this pod. There is one small problem, that the Calico is using full mesh networking for BGP by default, and it's not very good for a production. If you have, for example, 1,000 servers, then you will end having 1,000 BGP sessions, and you will also need to configure 1,000 nodes. And if you will have 1,001 server, then you will need to configure the previous 1,000 servers to peer with this node. And it's really not very comfortable. So we are using something called route reflectors if there is many nodes. And the route reflector is a daemon who knows all the information about the network. And at this picture, these two servers are like a route reflector. You can see that these hosts are not peering with each other, but they are peering just to the route reflectors. And these route reflectors then distribute information to other nodes. You should have at least two route reflectors to have a failover and keep your network running even if one of your route reflectors will fail. And there is another issue which you need to solve, that somewhere between the computes and the network, you will have some legacy networking, like some routers and this kind of stuff. And you will need this legacy networking to be aware of your Calico network. So you need to peer all your routers with Calico network. And I think that you really don't want, if you will add the compute node here, you really don't want to reconfigure all your network. So that's the reason why you are peering only with the route reflectors. So the summary of the Calico, the main pros is probably that there is almost no overhead. There is no inner or outer header in a packet. And each packet is routed from the source to destination directly. And it's using kernel routing. And this kernel routing is already in your kernel for years. And it's running the significant part of the internet. So I think we should trust it. The Calico is really simple. You will just need ATCD and the BERT daemon. So it reduces complexity, and there is almost nothing to break if you will break the ATC. It's using normal industry standards like a BERT, and it's easier to troubleshoot if you are familiar with this kind of legacy networking. However, there are some cons too. So you need to have underlay which understand your Calico network. So it's underlay dependent. And the cooperation between the underlay and the overlay networking is required. For example, if you will try to run Calico on your OpenStack with OpenContrail, then the OpenContrail has something which is called reverse path forwarding or filtering, and it will drop your traffic from pods to services back. So you need to configure your underlay networking to be aware of the Calico. And the last thing is that there is no layer 2 connection between your pods on the different hosts. So if your application requires this, so you are stuck and you need to use different kind of networking. So how the Calico works with Kubernetes? It's using CNI plugin, and we have two options for data store for storing the Calico architecture and configuration. There is an ATCD data store and Kubernetes data store. We are using the ATCD one, and I will describe the reasons for it later. And the Calico also supports Kubernetes policies, so you can enforce the policies on your network. And this Kubernetes policy enforcing is working even if you don't use Calico networking. It can be used only for enforcing the policies. So we have some production consideration for Calico. You always use separate ATCD cluster for Calico. There are two main reasons. One reason is if you will be doing, for example, some upgrades for Kubernetes. For example, if you are upgrading from version 1.5 to version 1.6, you will be probably upgrading the format of ATCD, and if you will break it, it's totally fine for your workloading containers. It will keep running. But if you will break the network, you can get huge problems then. So it's better to have separate ATCD cluster for Calico. And the second reason for this separation is that you probably want to have a high performance on your ATCD to be for your networking control plane to be as fast as possible. Another consideration is always use ATCD version 3 because it brings huge performance improvements. And you should disable BGP full mesh peering. Use route reflectors as I described before. And the last point is that we prefer to run Calico node as a systemd service and don't run it as Kubernetes manifest using kubelet. This is not a technical problem, but it's easier for us to operate these solutions. And we already have an ecosystem of the tools. So for operation guys, it's much easier to have a service than to need to tackle with Kubernetes manifests. But as I said before, it's not a technical problem. You can run it in manifest, but the running as a systemd unit file, so it's our solution much more. So now we are on the second part, on the OpenContrail. I'll give you the overview of OpenContrail networking. And the reason why we decided to evaluate the OpenContrail networking is that the first, that we think that it brings features which are missing in other networking plugins. And we have been using OpenContrail for almost 3 years. And we started with OpenContrail as a plugin for OpenStack Neutron. And we wanted to seamlessly integrate Kubernetes networking as well. And we have been evaluating OpenContrail plugin for Kubernetes since it was released. So the summary of the OpenContrail, as I said before, it's an overlay solution. It means that there are some encapsulation, and each packet, which is going from container to the outside of the world, or even from container to container, is encapsulated. It means that it's packed in another packet. OpenContrail itself has a lot of services. It's kind of hard to operate it. So you have a control service, which is responsible for a control plane. It creates connection between the agents and gateways, and is responsible for exchanging the information. And you have a config service, and this config service is translating API calls, translating UI calls, and the other calls. Then you have a analytics node, which is collecting the data of Oreo flows, the performance data. It can measure your traffic and this kind of stuff. This is quite unique because I'm not aware of any other Kubernetes plugins which can do this kind of analytics. Maybe there are some of them, but I have not tested them yet. There is a database, and database is used for persistent storage of configuration analytics data. And last one is an agent, but maybe this one is the most important one, because agent is actually providing the routing. It's using the kernel module on your host, and it routes your traffic. OpenContrail supports multiple encapsulations. We are, for example, using MPLS over GRE and MPLS over UDP, and you can use VXLAN as well. And we usually use physical gateways as a tunnel endpoints for all the communication, for all the node source traffic. And there is an example of Kubernetes topology of the OpenContrail with Kubernetes. And here on the right side, you can see that there are two OpenContrail controllers with XMPP session with connected to vRouter agents. These are the hosts. These are the vRouter agents running on your compute host, and it's using XMPP. Yeah, it's exactly the same technology which was used for communication in Gtalk a few years before, but it suits quite well for OpenContrail. And each change here in the vRouter is propagated to the control plane, and the control plane is responsible for distributing it back to the agents. But compared to the Calico, you can do many more actions in here. For example, there is the analytics about it. You can filter it, and you can do any other thing which you want to do with it. And there is also the BGP peering to the cloud gateways. These are usually for physical routers. We use just these two of them, and they are like an endpoint to the outside of your underlying infrastructure. Just to don't present it in a confusing way, this is just for the control plane. You are not routing traffic in this crazy way, but your actual data traffic is routed directly from, for example, from your containers here. There is a direct tunnel for cloud gateway. So this is just the control plane. Data plane is direct and as fast as possible. And OpenContrail also has some pros and cons. I will try to summarize them. So first, it's underlay agnostic. It really doesn't care what switches are you using or what is the underlay network. You can see that there are just some connections in here. So you need IP connection, and there is some tunnel. So you need some network which is able to pass your tunnels, but nothing else. And it can provide advanced network features for you. You can have layer 3 connection, layer 2, different kind of VPNs, and it can also orchestrate top-of-the-rack switches for you, which is quite nice if you needed this feature. And one thing which is usually considered, that if you are using SDN, that people think that everything about the SDN should be the hardware software one, and the routers which we are using, the physical ones. So there is some kind of confusion, but don't think about these routers as an old machine with static configuration and covered with dust, since everybody is afraid to touch it. These physical routers are configured using BGP and OpenContrail, so it's dynamic ones, and it's part of these SDN networks. On the other hand, there are some cons as well. There is there is definitely some overhead. I will let on you to decide whether it's significant or not for your infrastructure. And it's adding some payload because you are wrapping packets with another packet. And the one thing which I really don't like about the OpenContrail is the complexity. There are many services, as I have listed them on the previous slides. There are many advanced network features, and it's quite hard to operate them. So you cannot just run systemctl start OpenContrail, but there are many of the services, and you usually run it on many nodes. I think 3 or 5 of them is fine to run it in something which is starting to look like a production. But unfortunately, we are here to help you with the complex solution of OpenContrail, and we have already built the tools for it. We have, for example, solved formula for OpenContrail, and if you will supply right configuration for it, it will deploy the OpenContrail for you. So how the OpenContrail is integrated in Kubernetes. There is something called Kube Network Manager, and it provides connection between the API server of the Kubernetes to Contrail config API. This Kube Network Manager reads the information from API server and write it to the Contrail. And on the other side, it also reads the Contrail information, and for example, writes IP addresses back to API server. And the huge difference is that there is no kube proxy in Kubernetes with OpenContrail, because all the traffic is handled by Kube Network Manager and the tunnels. So there is ACMP for a connection between the gateway and the containers, as well as for a connection between the containers. One thing which is quite important for us usually is that OpenContrail provides isolation on the network layer. So the pods are associated with the network according to the labels. If you have ever seen the definition of the pod, there are some labels and annotations, and you basically write the name of the networks here, and the Contrail will prepare the networks for you. You don't need to touch it or configure anything. And the networks are completely separated by design. For example, namespaces in previous version, like in Kubernetes, are more like groups. It's not easy to separate the namespaces. We have some tools now, but it started in a version 1.5 or 1.6. But for OpenContrail plugin, we have a total separation of the networks, and if you don't pair them together, so there is no connection between them. And of course, you can define fine-grained rules. I have some production consideration for OpenContrail as well. They are not only for Kubernetes, but for OpenContrail in general. You should always run separate Cassandra clusters for analytics. One is for config and second is for analytics, because analytics node can generate a really lot of traffic and the data, and it may overload the configuration, overload the nodes, and fill up your disks. So it's better to have 2 Cassandra clusters, because if your analytics is stuck, so you don't have a graph, so you are not happy with it, but your network is still working. And the second consideration is that it's better to use physical gateways. It's better from our point of view. You may be fine with the virtual one as well, but for a bigger deployment, I think that the physical gateways is a really good termination of the tunnels. So now I've presented you the Calico and the OpenContrail, and I will try to compare the solution that I was talking about, and I will present our point of view about the architecture. Please keep in mind that your results may be different, and it really depends on the architecture and the requirements. So OpenContrail performance really depends on the encapsulation. We get the best results when using MPLS over UDP between the containers, and MPLS over GRE between the containers and the gateways itself. But these results really depends on offloading on your network interface. So if you have a different networking interface, you will get totally different results. And the OpenContrail, as I mentioned before, is using encapsulation, and there is about 4% of payload overhead. But still, these results really depends on your traffic and on your use cases. So in our particular test case, it was about 4%, but it may be totally different for you. On the other side, Calico is using no encapsulation, so there is no overhead. The packets are just routed to their direction. And we are usually running all these tests on Ubuntu. It's currently Zenile, but it really depends. I'm having there some numbers, but I think that the bandwidth is almost the same in this case, but it may be really different in terms of packets per second. But the question is whether the packets per second is really important in containers. This metric is commonly used for NFV features, like if you are running, for example, firewall or this kind of stuff. But does we really care about packets per second in containers? It depends on your architecture and on your workload. For example, if you are running, I don't know, web servers or HA proxy, from my point of view, it's much easier for you to do horizontal scaling than the vertical scaling and adding more bandwidth. It's much easier to have more containers and load balance it. So it depends on your use case. And it's not possible, easy or wise to stick with some solution, because none of them is perfect. Everyone has a pros and cons. So what about if we'll take advantages of OpenContrail and Calico and use them together? There is our testbed for MCP, and you can see that it's similar to OpenContrail. We are using OpenContrail installation with cloud gateways, and we have 2 physical nodes. There is just an example, we usually have more of them, but there are 2 physical nodes running Kubernetes with OpenContrail, and they are connected directly using XMPP to Contrail. But in some cases, you need to have separated clusters for developers or for some applications, and we are able to peer these Calico instances directly with route reflectors and exchange all this information with Contrail. So we seamlessly integrate the OpenContrail if it makes sense for you, and you can run Calico as well. So you can take advantages of all the solutions. For example, we are using this to run physical servers together with the Kubernetes and together with virtual machines. So we can provision Kubernetes virtual cluster and be peering with the physical clusters. And in many use cases, it's not possible to run everything in a container. There are the technical problems, as well as the legal problems. You can guess which problem is harder to solve. Of course, the legal ones. We can solve all the technical problems, but the legal ones are usually much harder to solve. So, for example, if you are running some database servers which are licensed per hardware or this kind of crazy stuff, you need to use a different architecture like this one. And you can easily connect physical nodes with virtual machines and as well as with the containers. We tested these use cases and it's working very well since it's seamlessly integrated and all the tunnels are terminated at cloud gateways. You are using OpenContrail as well as Calico together. So you can fill all the requirements with OpenContrail networking and use Calico when you don't need these rich features. And there are use cases, and many customers has reported them that they have some strict rules which need to be passed, and even for container networking. My favorite is that some of them need to whitelist connection to database, and so they are trying to make the IP address of the pod fixed, because it's hard to whitelist IP address if the pod IP address is changing all the time. And you cannot handle it with default Kubernetes networking, but you can fill these requirements with open container networking because you will just isolate it on a network layer. And I have some Kubernetes production recommendations as well. Always build your own binaries. For example, we have a Calico team which is building Calico and applying some patches for us. So we are not using containers for unknown source, and we are using our downstream sources. It's necessary to decide if you really need high available cluster. Sometimes it may be better for you to use simpler cluster or smaller ones, even with just one etcd server. And if you don't need to spin pods very quickly, and your workloads are more or less static, so you can be fine with just one etcd server. Another recommendation is use systemd and not run in manifest, but it really depends what suits you well. And we are trying to avoid mixing many technologies like a Bash and scripting in Bash and Ruby and Python together. So we are happy with SaltStack, and all our formulas for SaltStack are available in GitHub, even for open contrail stuff and this kind of stuff. So we are trying to avoid mixing the technologies. And now, in the few last slides, I'll try to compare the Calico and open contrail. The Calico is not using any encapsulation, and open contrail is supporting MPLS over GRE and UDP, but you can use VLANs as well. Yeah, there is a row with bandwidth, but I don't want to decide whether it's important or not. I think that get these results on 10 gig network for container may be totally fine, even if you are using Calico or open contrail. And one of the features which can be required for you is a security and multi-tenancy. Open contrail provides you with native overlay, isolation, and creating networks according to labels or namespaces. And the Calico have implemented Kubernetes policies. You can easily run open contrail on multi-clouds, so you can orchestrate bare metal, VMs, and containers. But it's much harder for Calico. There is some project which integrates OpenStack and Kubernetes into single Calico, but I have never seen it in production yet. A big disadvantage of open contrail is that it's really complex. There is a Cassandra, Zookeeper, Redis, Kafka, and almost every technology which you can think about it. So on the other hand, Calico is really simple. There is just etcd and BERT, and BERT is already managing significant part of the internet, so I think we should trust it even for managing our container workloads. Calico has some extra features like bare metal extensions, like automatic provisioning of Tor switches, different kinds of VPNs, and analytics. So there is our testbed. We are testing the Kubernetes deployment in this testbed. You can see that we are using open contrail and running OpenStack with open contrail. And then we are deploying Kubernetes in VMs using HeatStack or something like it. And this one is used, I think, only for open contrail. And we use HA proxy and keep alive to provide single endpoint for control. Because if I have, for example, 3 API servers here, here, and here, I need single endpoint for my computer, because if I will try to run kubectl, I would like to reach API server which is alive, so I cannot configure just one. This keep alive is not required for some services which can handle many servers together and doing load balancing on their own. Of course, you can use some external load balancer if you have this kind of device on your network. So it was everything which I prepared for you. Thank you for your attention. Thank you for your time. And I'll be happy to answer your questions on the Slido. In case there will be no questions, you can catch me anytime and we can talk about Kubernetes stuff or other storages. or anything you want. Okay, thank you, and have a nice day.